In this video, we're going to use row operations to solve a system of linear equations in two variables. It says given 4a plus 4b equals 4 and 14a plus 18b equals negative 18, use Gaussian elimination to solve the system. So the first thing we want to do is we want to write this into an augmented matrix. So an augmented matrix is where you have all your variables on one side. So this would be like A1, 1, B, 1, 2, A, 2, 1, and then B, 2, 2 on the left side of the equation. And then you put this line here, which really means equal, and then you're going to put all the numbers that you're equal to, and I'm just going to say constant. This would be 1, 3, and then constant, this would be 2, 3. So we're going to make an augmented matrix with these two equations. So to do that, we're going to write 4. So these are all coefficients of the variables. So this would be like the, if you can tell by the A part, this would be the A variable column, this is the B variable column, and this is the constant column. So we're going to write 4, which is the leading coefficient on the first equation, plus 4, which is the leading the other coefficient on B, and then we'll write 4 here. And then we're going to say 14, 18, and negative 18. Now our goal is to get the identity matrix. The identity matrix is when you have 1, 0, 0, 1. This is called the identity. So I'm going to kind of mark that here, identity matrix. And when you get there, you can see that what's nice about the identity matrix is this would be, if this is the A column, in the first row, A would have some coefficient, but B would not. So you would just have A equal to whatever constant was out here. I'm going to say constant 1, 3, and then this would be constant 2, 3. So we want to get this because we would have A equal to whatever this number is, and then B equal to whatever this number is, and we'd have the system solved. To do that, I can do row operations, just basically like elimination and substitution with normal systems of equations. I can divide, I can multiply by any number as long as I do to each term for the row, and then I can add and subtract rows together. I can also swap rows, so I could just basically put this equation on top and this equation on bottom, and that wouldn't make any difference either. So the first thing I'm going to do is I'm going to divide the top by 4. So I'm going to say row 1 divided by 4. So when I do that, that gives me 1, 1, 1. Now when you do things with matrices, I'd suggest that you write this whole explanation of what you're doing with each row so that you can trace back if you make any mistakes. I'm also going to do row 2, and because they're all divisible by 2, I think I should divide them all by 2, so I'm going to do row 2 divided by 2. 7, 9, and that'd be negative 9. Now I'm going to try to get these this bottom left corner canceled to be 0 first. That's my goal, is to get this identity matrix going. So I'm going to get 0 here, 0 here, and then I'll worry about making these 1s. Now it just happens that this is a 1, but I didn't particularly go for that. I'm trying to get 0 for the bottom left and 0 for the top right to start. So we're going to multiply negative 7 times row 1 so that we're opposite signed. That's negative 7 minus 7 minus 7 there, and that's 7, 9, negative 9. And now I'm going to take and I'm going to say that I want row, well, I better write it here, row 2 equals row 1 plus row 2. So I'm going to add row 1 and row 2 together. Negative 1 or negative 7 and 7 gives you 0. So I'll rewrite the top equation, which would be negative 7, negative 7, negative 7. And then when I add these, I get 0, 2, and that'd be negative 16. Right, I'm adding these two things together. Negative 7 and 9 was 2. Negative 7, negative 9, negative 16. And then, once I get to that point, I'm going to, again, divide by this negative 7. So I'm going to say row 1 divided by negative 7. And when I divide each of those, that'll give you 1, 1, 1, 0, 2, negative 16. Now I'm going to try to cancel the top right piece. This top right, this would be the row 1, column 2 spot. I want to make that 0 so that I get this identity matrix. To do that, I'm going to divide the bottom row by negative 2. So let's go row 2 divided by negative 2. When I do that, that's going to give me 1, 1, 1 still on top. And then on the bottom, I'll get 0, negative 1. Divide this by negative 2, and I get 8. Now I'm going to take and I'm going to add row 2 to row 1, and that'll be row 1. So I'm going to say row 1 equals row 2 plus row 1. So I'm going to add this row to the top row, and that's going to change the top row. And when I do that, I get 0 plus 1, that's just 1. Negative 1 plus 1, obviously 0, that's what I was going for. 8 and 1, that's 9. And then at the same time, after I add that, I'm going to, well, you know what? No, I'll do it 2 separate steps. This is 0, negative 1, 8. So you can see I'm close to having the identity matrix there. So I'm going to divide or multiply by negative 1. So I'm going to say row 2 divided by negative 1. And when I do that, I get 1, 0, 9. And this would be 0, 1, negative 8. So my solutions here, remember this is the A column and this is the B column. A is equal to 9 and B is equal to negative 8. So my coordinate there would be 9 comma negative 8 for my solution.